Hey, welcome to the channel. In this video series, I'm going to share my journey to learning the Rust programming language by trying to build a RESTful API. I've been a Ruby developer for the past 15 years, and around 4 years ago, I've discovered this amazing new programming language for the front end called Elm. And it had such a tremendous impact on my development experience that I wanted to have the same experience on the back end. So I took a look at the programming language landscape and I narrowed my list to two options. First one was Haskell, which is almost perfect, except it feels dated and the community around it feels less vibrant. And the second option is Rust. I picked Rust over Haskell because it feels modern, it's got an amazing community and incredible momentum. So my plan is to use two books, the official docs, and Google for reference and see how far I can get. The books are Rust Web Programming and Programming Rust 2nd edition. But first, I'm going to spend some time configuring my environment. To find the installation instructions for Rust, you can go to rust-lang.org and click the Install tab. Here you can see that curl command, which you can just copy and paste in your terminal. This will install a default stable version by downloading the required packages. After the installation is done, all you have to do is to source the cargo/m file. After sourcing that file, you should see a few Rust commands available. You could also install a nightly version if you want to by using the rust up command. This, again, will download the packages and install the new version, as you can see here. The rust up command is a version manager for Rust. You can use it to install different versions of Rust, look at the versions you have installed, and switch between versions. With Rust Up Default Stable, I can switch to the stable version. Now let's install some packages for the VSCode editor. First one we're going to install is Rust Analyzer, and the second one is called Code LLDB. Okay, so it's time to look at some code. We'll start by looking at strings because that's the first thing in this book. So with Rust, you can create a main function by doing fn main, and then inside the curly braces you put the body of that function. So the first thing I want to do is write a hello world program. And to do that, I can use the println macro and give it a string. And if I try to compile that with Rust C, you can see that it prints hello world. So now let's take that a step further. I'm going to move the printing into a different function. We'll call this function print. This print function will take an input string of a type that I'm going to omit for now. We'll come back to it in just a second. And we're going to call the print function from main, passing in the string. And then inside of the print function, we'll call the println macro and pass it the parameter. So for this to work, the type of the input string parameter needs to be of type string slice reference. The ampersand there means reference and the str means string slice. So it's a pointer to a string and it's got a size so that the function knows how long the string is. Now if we compile this, you'll see that it prints hello world. The string slice reference is allocated on a stack and its size is known at compile time. But what if we want to use a string for which we don't know the size? For that, we can use the capital S string type. This string is allocated on the heap and its size is unknown at compile time. For this to work, we need to convert our str string or our string slice to a string type. And we can do that by calling the toString method. And as you can see, if we compile this, we'll get back hello world. So now let's look at how we can pass that string slice by assigning it to a variable. We can create a variable with let, and then we can assign the string slice to it. And then we can pass the variable to the print function. Cool, so that's a high-level overview of how strings work. Now let's look at numbers. There's no reason to go into too much detail about numbers for now. The important thing to note here is that depending on how large the numbers are, the numbers that you're going to use in your application, you have to pick different types, because each type supports a limited range for numbers. And we have two kinds. One is signed and the other one is unsigned. And unsigned means that you're going to be using positive numbers, but the range is going to be higher. And signed means that you're going to be using both positive and negative numbers, but the range is going to be split into two. So the size of your number, meaning how much memory it needs, can be 8-bit, 16, 32, 64, 128. And in order to calculate how big the range is, for each one of those sizes, you can raise 2 to the power of the size. So for example, for 8 bits, you can do 2 to the power of 8 and you'll get 256. So you can have 256 numbers, but if you start from 0, your range is going to be 0 to 255. So the way to define an unsigned integer is to use the letter U and then the size. So for example, U8 will give you an 8-bit integer. And if you want to have a signed one, you could use I8, and that will give you a signed 8-bit integer. For floating point numbers, we have F32, which is a 30-bit float, and F64, which is a 64-bit float. Now let's briefly look at arrays and vectors. Rust has two types you can use to define arrays. The array type, which has a fixed size and it's immutable, and the vector type, which is mutable and thus it can change. Both of them can only hold values of the same type. The way you define an array is by using the square brackets. For its type, you need to provide a type of the elements it holds, followed by the number of elements. In this example, we're defining an array of type I32, which will hold 3 elements, the numbers 1, 2, and 3. If you want to iterate over the array, you can use the for-in loop and the iter method on the array. Trying to push a value to an array doesn't work. Rust will show you an error. To define a vector, you use the vec macro. And to define the type, you use the vec type and then the type of the elements it holds. So in this example, we're defining a vector of string slices which holds the strings 1, 2, and 3. And just like with arrays, you can iterate over the vector using the for-in loop and the iter method. But because the vector is mutable, you can add more values to it. To illustrate this, let's use push to add an element to a vector. As you can see, I'm defining a new vector that holds the A string, and I'm pushing the B string to that vector. And if you want to assign the vector to a variable, you need to define that variable as mutable in order to be able to push the values onto the vector. Okay, now let's look at hash maps and how they work in Rust. Before you can define a hash map in Rust, you have to import it from the standard library. And the way to get a new hash map is by using the new function along with the variable you want to bind it to and the types for the keys and values. In this example, we're creating a new hash map with the keys of type string slice reference and the values of type I8. Then we're binding it to the mutable myHash variable and using it to call the insert method with the test key and the value 1. We can get the value out of the hash map's test key by using the get method with the key as its argument. One thing to note here is that the value you get back is not the I8 value, it's an option type. That's because fetching a key from a hash map could fail if the key doesn't exist. So with the option type, you either get the value wrapped by some, or if the value doesn't exist, you get back the none type. And we can also check this by using the assert equal macro. And to extract the value out of the sum type, we can use the unwrap method or the match function. That should give you an overview on how hash maps work in Rust. Now let's look at errors and error handling. When we tried to get the value out of the hash map key, Rust gave us back an option type. It does that to handle the possible error case. If the value exists, it gives you one type, namely the sum type, and if it doesn't, you'll get back the none type. That is a form of error handling, but Rust also has one more wrapper type for handling errors, which is called result. The result type has more information about the error than the option type does. With the option type, you don't have any information about the none branch. It's just letting you know that it's not a value. But with the result type, you get to wrap values in both branches. It looks like this. In this example, we have a function called errorCheck, and it takes a Boolean value. It returns a result type where the success branch wraps an I8 value and the error branch wraps a static string slice reference, meaning a hard-coded string. We have a few ways we can use the result of that function. The first one is to use a match function, where you can handle each branch and their wrapped values. The second option is to unwrap the result, but in the case of an error, it will panic and stop the program. The third way is to also unwrap the result with a message, in which case, if there is an error, it will still panic, but you'll see the message you provided in the backtrace. You could also check if the result is an error with the isError method. And you can throw errors if you want with the panic macro. Hopefully this gives you a rough idea of how errors and error handling works in Rust. So I hope you enjoyed this first video in the series, and if you want to keep watching me stumble through the learning process, don't forget to subscribe to the channel because I'll be posting a lot more videos just like this one. See you in the next video, bye!